Chapter 1 is about graphs and data, graphing of data, and calculating statistics and how we can interpret all of that. So we'll start with 1.1, which is bar graphs and dot plots. Here's some vocab that you will be introduced to and need to know. So this first thing is a pictograph, and a pictograph is something we don't often see and use that much, but it is a kind of graph, and it's important to recognize. So, um, in this birthday one, we have a key down here that tells us that each person is 5 students. Um, so that gives us information about how many are in here, right? So instead of 3 people having their birthday in January, we actually have 15. Then here in this CD sales pictograph, we have one CD is represented in this picture of a CD. So when we count them, this one for classical music means actually one. And a pictograph is simply a graph where you have a picture to represent a certain amount of data. And then we can take this pictograph and we could make a table of values for it, right? So I've got my categories of birthday month and how many people there are in each. Excuse me. And then here you can see that they've taken this pictograph and turned it into a bar graph. Okay. And so here it's important to see that we have our categories here, right? The month is the category, January, February, March, and April. On our y-axis, we have the number of students. Okay, and the bar goes for how high it would be, right? So here it goes up to 15, again, because these 3 people up here represent a total of 15 students because each person is 5 students. Okay, so this is a bar graph. This is a pictograph over here. Okay. So a couple of things that are important about this is that bar graphs gather data into categories and they make it easy to present it in compact form, right? We take all that information, we kind of put it together so it's easier to look at and we can quickly compare them. um, and we often use bar graphs for non-numeric data like months or colors, things like that. And sometimes we can also use it for numbers, but um, we can also do a dot plot with numbers. And so I'm going to show you a dot plot. This is an example of a dot plot. And normally, if we were in school, you would do an investigation and make this, but we're not. So here is an example of people took some pulse rates, and then this is what they got. So notice that the axis here, the x-axis, is numerical. It's not categorical. There's numbers here. And our numbers follow a normal number line. So each interval is representing the same amount. So in this case, each tick mark is 1 beat per minute. Okay, and they've labeled every 4, so 4 beats per minute intervals. And those are the same length. Every dot that's above there represents 1 data point. Okay. So it does have a similar look to a bar graph in the sense that when things stack on top of each other, you can see how many are in that. But the big thing here that makes it different is that the axis is numbers on a number line. Oh, wait. Range is a statistic that we get, and it tells us the spread of our values. So we just take the high, the maximum, which is 96, minus the minimum, which is 56, to get 40. So the range for this data set is 40 beats per minute. Okay, and then just some vocab words. That statistics are measures that you gather from your sample and any values you calculate using these measures. So um, when we have a sample, we take some data and we get that. And then when we calculate something like the average or we get the range, those are called statistics because we got them from the data, but they aren't the data itself. Um, the other thing we'll talk about is a population is we have a sample which is part of a population. So if I took the heart rates of 20 people and I found that the average heart rate was 70 beats per minute, I might say that people of that age, let's say if we were doing high school students, I might say that high school students in general probably have an average of 70 beats per minute. That's kind of what that is. The population would be all high school students, and the sample is the 20 kids that I took heart rates for. Okay. And then we'll also talk about things being biased, which is any sample can be biased. We could pick if I just pick athletes, that would be a biased sample of the population. If I um, just picked people who never moved, that would be biased, right? Those are biases that we have to think about. And that's basically the information that you need to complete the problems for 1.1.